Hello, you're welcome to Blessed Excellence Center. In today's video, we are looking at electromagnetic calculations. And your presenter is E.B. Christian. Now let's look at this question here. Here we have a question. It was observed that a photon has an energy of 8 electron volts. What will be the energy of this photon in joules? Calculate the frequency and the wavelength of this photon in nanometer. Now let's see how to tackle this question. First thing you do is to write out the parameters. Now the energy of photon is given in electron volt to be 8 electron volts. Planck constant has a constant value of 6.626 times 10 exponent minus 34 joules. And then the speed of light in vacuum has a value of 3 times 10 exponent 8 meter per second. Then 1 meter is equal to 1.0 times 10 exponent minus 9 nanometer. And then 1 electron volt is equal to 1.602 times 10 exponent minus 9 joules. Therefore, 8 electron volt, that is, since 1 electron volt is equal to 1.602 times 10 exponent minus 19 joules, therefore, 8 electron volt would be equal to 8 times 1.602 times 10 exponent minus 19. And that gives us 1.282 times 10 exponent minus 18 joules. Therefore, the required energy in joules is 1.282 times 10 exponent minus 18 joules. So the thing is just cross multiplication. Since 1 electron volt is equal to this, therefore 8 electron volt equal to 8 times this. Understand? So that is how that is obtained. Now let's see how we can calculate the frequency. Now from the formula that E is equal to hV, it follows that V, if you make V the subject, remember E is the energy, H is Planck constant, and V is the frequency, the required frequency. For more information on the formula, watch my video on Bohr models. You'll get all these formulas. They are listed there and explained in detail there. Okay. Now E is the energy we just calculated in joules, V is the required frequency, and H is Planck constant. So by substitution, if you substitute, first of all, from E equal to HV, if you make V subject, divide both sides by H, divided side by H, divided side by H, you have that V is equal to E over H. So in this formula now, substitute for E being the energy of electron, and then substitute for H being the Planck constant, and that gives you 1.282 times 10 exponent minus 8 joules. Remember, that's the value we obtain when we convert the electron volts to joules. Okay, then the Planck constant has a constant value of 6.626 times 10 exponent minus 34 joules. So if you divide this by this, you're going to have 1.935 times 10 exponent 15 per seconds. The unit of frequency is per second or hertz, that's something. Therefore, the frequency is 1.935 times 10 exponent 15 per seconds. All right. Now let's see how we can calculate the wavelength. Now from the formula that C is equal to lambda V, if you make lambda the subject of the formula, divide both sides by V, divided side by V, you have that lambda is equal to C over V, where C is speed of light, V is the frequency, and lambda is the required wavelength. By substitution, if you substitute for speed of light and frequency, you will have that lambda is equal to C over V, which is equal to 3 times 10 raised to the power of 8 meter per second, all over 1.935 times 10 exponent 15 per seconds. So if you evaluate this, if you divide this by this with calculator, you're going to have 1.55 times 10 exponent minus 7 meters. Okay, that is the unit of wavelength, that is lambda. Okay, but we are asked to calculate the wavelengths in nanometer, so we have to use the relationship that 1 meter is equal to 1 times 10 exponent minus 9 nanometer to convert. So here you have that, but the wavelength is required in nanometer. We therefore convert the value in meter to nanometer. Here we got 1.55 times 10 exponent minus 7 in meters. So we have to convert from this meter to nanometer. So we now say, since 1 meter is equal to 1.0 times 10 exponent minus 10 nanometer, therefore 1.55 times 10 exponent minus 7 meter, being the value we obtain in meter here, see the value, will be equal to, you cross multiply this, okay? This, okay, this is meter, okay, so this, therefore that will now be equal to 1.55 times 10 exponent minus 7 divided by 1.0 times 10 exponent minus 9, and that will give you 1.55 times 10 exponent 2 nanometer. So exponent 2 is the same thing, 10 exponent 2 is 100. So 100 multiplied 1.55 gives you 155 nanometer. Therefore, the required wavelength in nanometer is 155 nanometers. Thanks for watching. Do it to subscribe at Blessed Excellence Center. Big.